Welcome to this AWS hands-on tutorial where I'll walk you through creating a custom VPC with both public and private subnets. The VPC will be created in the US East 1 region with subnets in the US East 1A and 1B availability zones. We'll add a Bastion host in the US East 1A public subnet, which will allow admin access to the EC2 instances in the private subnets via SSH. And we'll put a NAT Gateway in the US East 1B public subnet, which will provide outbound access to the internet from the private subnets for updating and patching of the application servers. To get started, I've logged into the AWS Console, and I'll navigate to VPC. I'll click Create VPC, select VPC only, give the VPC a name, and an IPv4 CIDR of 192.168.0.0/24. Then I'll create the VPC. With the VPC created, I'll jump over to subnets and create my 4 subnets, 2 public and 2 private. I'll click Create Subnet, select my VPC, and give this subnet a name of Public 1. I'll put it in the US East 1A availability zone and give it a CIDR of 192.168.0.0/26. I'll add another public subnet, put this one in US East 1B, and give it a CIDR of 192.168.0.64/26. Now I'll create the 2 private subnets. The first in US East 1A with a CIDR of 192.168.0.128.26, and a second in US East 1B with a CIDR of 192.168.0.192.26, and I'll create the subnets. Now, with the subnets created, I'll jump over to Internet Gateways and create an Internet Gateway. And attach it to my VPC. Now I'll jump into route tables and create my public and private route tables. The first I'll give a name of public route table, select the VPC, and click Create Route Table. Then I'll do the same for the private. Now I'll click on the public route table and edit to add a route to 0.0.0.0/0 and target the Internet Gateway. Then edit the subnet associations and add the 2 public subnets. Then I'll click the private route table and leave the default route for now, and later I'll come back and add a route to the NAT Gateway. But I'll edit the subnet associations to the private 1 and private 2 subnets. Now I can focus on creating the Bastion host in the US East 1A public subnet. But before I do that, I'll need to create a NACL. So I'll jump over to Network ACLs, then click the Create Network ACL button and give this NACL a name. Select the VPC and create the NACL. Then I'll edit the inbound rules and add Rule 100 for SSH from anywhere. Now, normally you'd want to lock this down to your personal IP address, but for this demo, I'll just leave the source as 0.0.0.0/0. I'll add Rule 110, which is a custom TCP rule, with the port range of 1024 through 65.535 for the ephemeral ports, and give this a source IP of 192.168.0.0/24 to allow inbound traffic from the app servers. I'll save the changes and edit the outbound rules. For rule 100, I'll create a custom TCP type for the ephemeral ports and leave the destination as all zeros. Rule 110 will be for SSH with the VPC CIDR. Then I'll edit the subnet associations and select the public 1 subnet. Now I'll jump over to security groups and create a security group for the Bastion host. I'll add an inbound rule for SSH and point it to anywhere, although again, you should lock this down to your IP address. And add an outbound rule for SSH to the VPC CIDR to SSH into the app servers. And create the security group. Now, I'll jump over to EC2 and launch a new instance for the Bastion server. I'll use Amazon Linux 2 for the AMI, keep the default T2 micro, create a new key pair, and edit the network settings and select the public 1 subnet. Ensure to enable auto-assign public IP, and then I'll select my Bastion security group and launch the instance. With the instance running, I'll copy the public IP, jump into a terminal, and chmod 400 my key pair. Now I can SSH into the Bastion host and see we're connected. Now I'll jump back over into the VPC and configure a NACL for the private subnets. I'll create network ACL, give this a name, and select the VPC, then edit the inbound rules. For rule 100, I'll add an SSH rule from the Bastion host. Rule 110 will be all ICMP traffic for everyone. And 120 will be custom TCP for the ephemeral ports with access for everyone. This will allow internet traffic to return back to the app servers for patching and updates. From here, I'll save changes. And now I'll edit the outbound rules. Rule 100 will be for HTTPS. 110 will be for all ICMP traffic. And Rule 20 will be custom TCP for the ephemeral ports, and I'll save changes. And finally, edit the subnet associations and add both private subnets. Now I'll jump into security groups and create a security group for the private subnets. I'll add an inbound rule for SSH from the Bastion host, and outbound rules for HTTPS and all ICMP from anywhere, and create the security group. Now I can jump back over to EC2 and launch a new instance in the private 1 subnet for an application server. Again, I'll use the Amazon Linux 2 AMI, a T2 micro, select my existing key pair, and edit the network settings. I'll select the private 1 subnet. This time I don't need to auto-assign a public IP. Select an existing security group, which is the private security group I just created, and launch the instance. Now, with the app server instance running, I should be able to SSH into it from the Bastion host. And to do that, I want to add my private key to my local machine's keychain so I can SSH into the app servers from the Bastion host without having to put the private key on the EC2 instances. So I'll execute SSH add -K and give it the name of my PEM file. Now I can SSH -A into my Bastion host, and I'll jump back over to EC2 and copy the private IP for my app server and SSH into the app server from the Bastion host. And we see we're connected. Now that we're able to connect to the app server from the Bastion host, the next thing we need to do is add a NAT Gateway in the US East 1B public subnet, which will allow access to the internet from the EC2 instances in the private subnets. So I'll jump back over to the VPC console, go into Network ACLs, and create a new Network ACL named Public to NACL in my VPC. Then I'll edit the inbound rules, add Rule 100 for HTTPS, Rule 110, which is a custom TCP for the ephemeral ports, and 120 for custom ICMP, and then save changes. And as I'm looking at these inbound rules, I see I've actually made a mistake. I don't want to allow HTTP access from anywhere. I want to allow it from the CIDR of my VPC. For the outbound rules, I'll add Rule 100, again for HTTPS, Rule 110 for the ephemeral ports, and give it the IP of the VPC. And finally, Rule 120 for ICMP traffic, and save changes. And then edit the subnet association and select the Public to subnet. Now I can click on NAT Gateways and create a NAT Gateway and put it in the Public to subnet. Associate an elastic IP and then create the NAT Gateway. Finally, I need to go back to the route tables, select the private route table, and add a route to the NAT Gateway and save changes. Now, with all the infrastructure in place, I should be able to jump back into my terminal, and I'm still connected to the app server instance, and ping google.com, which is successful. And that concludes this tutorial where we created a custom VPC with both public and private subnets. We added a Bastion host in one of the public subnets, which allowed us to SSH into the EC2 instance in a private subnet, and also added a NAT Gateway in the other public subnet, which provided internet access to the EC2 instance in a private subnet. I hope you found this useful, and I also hope to see you again in another Cumulus Cycles tutorial.